All right, I'd like to go ahead and announce our next sponsor and get the next, next speaker and get our next talk going. So our next speaker is Josh Elser. Josh is a software engineer at Hortonworks, longtime Accumulo community member, very active in the PMC. So with that, I'll hand it over to Josh. Thank you.
Thank you. So today we're going to talk about iterators, specifically how to actually effectively test them in some manner that gives you some more confidence over what you have previously been able to do with Accumulo. So quick blur about me, like Dan said, I've been with Hortonworks for almost 3 years now, like almost to the day. I started out really at Apache, getting involved first with Accumulo. When it first hit the incubator, getting involved in that regard, it's kind of, I could say in a nice way, it's blossomed. In other ways, it's exploded. Involvement in other projects at the ASF, even mentoring other podlings who are trying to become their own products now, in addition to joining the foundation itself as a member and taking on foundation level responsibilities. So disclaimer, all these sorts of things, when you see the short name, these are all trademarks of the ASF. Use the full name when you can. So, Accumulo, typically when you're first talking about to somebody, you're really hard pressed to not mention iterators. They always seem to come up. They're one of the probably the most prominent novel feature on top of the original big table design. Probably second to maybe only cell level visibility. In this presentation, just to be clear, iterators, when we're talking about Accumulo iterators, we're really talking about sorted key value iterators. That's just a real big mouthful. So we'll abbreviate that to iterators, and just to be clear. The reason we really like iterators is because they give us this framework that we can actually offload computation from clients to the servers. So running typically on your system hardware, not on your dinky little laptops. You can, again, following the Hadoop paradigm of actually pushing the computation down to the data, avoid the overhead of sending data over some smaller pipe. One of the interesting stories, I think one of the original developers on Accumulo somehow landed a lunch with Jeff Dean, who was one of the authors on the original Big Table paper. Somehow he got at Google, went to the Googleplex. I hope they actually had lunch at the Big Table, which is one of the cafeterias there. I'm not sure if that was actually the case, but supposedly iterators were actually pitched to Jeff Dean, sort of, hey, well, we built this system on top of what you described in Big Table, and supposedly he actually said, oh, that was pretty cool. So internally in Accumulo, we can do a lot of different things with it. I won't bother reading all these off, but there's a lot of benefits, and we really like them. So some of the things we actually can do, so if you pull down Accumulo off the shelf, there are a number of iterators that you can just pull down using your code and actually get some sort of optimization without having to really think about it too much. You can do sort of slices over data. So if you have some set of columns in a row, maybe you only want a certain number of columns, maybe a certain range, you can do this efficient filter without having to implement this custom logic on your own. You can do some basic mathematical statistics, so computing min, max, averages. You can just do these off the shelf. You can do read over your data set and compute some statistics without, again, having to do it on your own. You can do sort of complex aggregations over some serialized representations. So say you're storing arrays in the values. You can concatenate a bunch of different arrays together, and at your client, all you see is one large array. You don't actually have to know how the data is stored in Accumulo. You're just seeing some nice representation. Same with aggregations here with the whole row iterator and whole column family iterator. You can do these sort of manipulations on the fly to get a sort of tweaked view of what's stored actually in the table. Russ actually did a really good job in his keynote and actually really prepped me showing how you can actually do these sort of transformations on the fly with iterators. And that's really the power of why we'd like to do these. So we'll take a step back now and think about more the big table architecture itself and how these iterators actually fit in, because I don't like talking about them as some magical thing. Like they're a construct, we want you to use them, they should be well understood, and it's not that tricky to understand how they actually work. So when your client is coming in to Accumulo, what they say is okay, here's a range of data I want to read from this starting point to this ending point. So what actually happens under the hood is that Accumulo has to take that range, so that one key to another key, turn that into a range, and figure out what tablet, so the physical partition of data, and figure out, okay, what server in my cluster is actually hosting that. So the client goes, talks to the metadata table, figures this all out, gets back location, and figures out what tablet servers it actually has to talk to. When it actually goes to that tablet server, what happens is the client issues a read and says, hey, I want to read this data. Please give it to me. What's actually happening behind the scenes is that this is a sorted merged read of two different data sources. You have the immutable files on HDFS. These are sort of the optimal way to keep these the data that you've already written once. You have the data stored in memory for the recently written data. They're all sorted, so we can just do a merge read over all of them. It's great, sorted data is awesome. And before we're actually sending that back to the client, we kind of hook in the iterators here. So we can suddenly say now, as we're reading over this coalesced view of the data for this tablet from these multiple sources on the cluster, maybe we're going to do some transformation before we actually send it back to the client. So again, Russ did a great job sort of prepping this here. Say we have some table of records about individuals. Individuals might have some siblings. They have some brothers and sisters. So we can have some representation where we actually list out the brothers and sisters in the table for each individual. So each row here is one person. But maybe we have some application case where we don't actually care who the siblings are at this time. All we want to know is how many siblings do each of these individuals have. Traditionally, you might have to go and create some other index of the table. You might have to run some ETL-style computation beforehand to actually figure this out, or you have to do it all in your client. The really nice thing about Iterators is that we can actually do this on the fly and sort of implement a dynamic view. We don't actually have to manipulate the data on disk. We don't have to store it in a different representation. We can do it on the fly and suddenly present at the application layer a different view over the same data that we're storing. Because this can be done in parallel on multiple tablet servers at the same time, clients typically, there isn't a huge impact in actually performing this kind of computation. It's just a very small amount of delta on top of what the tablet servers are already doing to reading the data. On the right side, so after you write some data into Accumulo, eventually it's going to be written into those R files, those sorted files, mutable files on disk. Eventually, Accumulo is going to come along and try to clean up these files. So each tablet, so each physical group of data hosted on a server, they're going to be collecting a number of files. After some amount of time, we don't want to keep letting those files grow unbounded because every file we have to open and read is essentially holding some amount of memory. So we're going to have some buffer to read data off a physical disk, read it out of the data node, read it into, do an RPC into the tablet server, and get this data back in. So every time we have to deal with a file, that's more overhead that we have to deal with. So ultimately, we want to reduce the number of files that we actually read in Accumulo and have to open to answer some query. So as we're combining one number or more than one file into one, we can again apply these iterators into it. So we can say, as we're reading these data, maybe we can do some sort of transformation or some modification. So if we take the same sort of example where we have these siblings, say we know that query we were talking about before. Some of our application use cases actually want to know the siblings. Maybe some of them only need to know the counts. Maybe we are actually querying the number of siblings very frequently, and we want that query to be as fast as we possibly can. Instead of incurring that latency every time we read, even though it is a small delta on top, we don't want to do that all the time because we know we're going to be doing it so frequently, so we can actually use iterators at compaction time to actually dynamically create a new column in the data without actually having to do another batch-style job to mutate the data. So it's this really powerful thing of letting us change the schema of our data itself, extract new attributes in the data we already have, and we get to all express it through iterators. That's sort of like the crux of why we really like these iterators and why we keep talking about them all the time. not only for you as individuals, this is a benefit, but actually internally in Accumulo, it actually is great for us as well. So I think we probably have like at least half a dozen iterators that are actually used underneath the hoods to implement the sort of semantics of Bigtable itself for you as a user. So things like cell level visibility filtering are implemented by an iterator. Things like masking deleted entries so you don't see them on the client is implemented as an iterator. Doing timestamp filtering, so if you only ask for records with a certain time, or removing multiple older versions of some key, these are all collapsed, and they're all implemented as iterators, and they give us this very uniform way for us as developers of Accumulo to also benefit in the same way you can at the application layer. It's really important to remember, though, when designing an iterator, that there is a lot of things that they are not. So kind of the square peg round hole sort of thing. They are not a database trigger, they are not a hook, and they are definitely not coprocessors as described in the Bigtable paper. And I would highly recommend against trying to make them do that. They may appear that they are doing something like you think, but long term it's really not a good idea. In a similar fashion, they don't replace a general distributed execution engine. So there are things like Hive, your Presto, your Flink, this is some of the new hotness here. Tablet servers are not meant to be a general purpose execution framework. Iterators allow us to represent a very constrained set of problems that we can implement safely and efficiently in Accumulo. But most of the time, if you have some distributed computation where you want to run a join across a 10 terabyte table, iterators are probably not going to be the way to do it. However, there are some caveats where we can actually, given some very constrained problem set, we can actually represent these problems in iterators. But in general, it's good not to think about iterators as replacements for these other things. So getting to actually building an iterator, it's a lot harder than you think. And I've been doing it for too many years now. The API hasn't really evolved. I think the same API has been there for probably longer than I've actually been working on Accumulo. It's not a bad API in terms of it lets you do what you need to do, and you have the hooks there, and you can implement things. It's great. But looking at it, you may not really understand, why is this method here? What does the method actually do? Are there side effects that I need to be aware of? So these are the sorts of things that you sort of get with this domain knowledge after working with it for a few years. Then you say, oh, right, don't do that. It's kind of exploded this one way 2 years ago, and I had to bring in donuts the next week. The whole fact that Accumulo itself is running on many nodes is also sort of exacerbating the same problem. It's not like you're running some single-threaded application on your desktop where you can just easily interact with the system. You can look at logs, you can attach a debugger. You actually have to first answer the question of, okay, if I want to figure out what's happening in Accumulo, I even have to figure out what node it's going to. And that's not guaranteed to stay the same. So all of the problems in actually debugging on a distributed system make actually debugging iterators even worse. So we sort of have two tools right now that, as a developer, you can use if you want to build your own iterator. So you answered the sort of question. You said, okay, I know that I have some problem. I can represent it, this computation in an iterator. I want to benefit from all this stuff. I know I'm not trying to do anything I'm not supposed to do. Great. So the first off is you can write your good old-fashioned unit test. Nothing fancy. I don't want to give a talk on writing unit tests. There's probably much better people who you could listen to about how to write unit tests than I can. But the general premise is you can break in some function of some piece of code, some class here. You can break it down into discrete tasks that you do. Give an input, you expect some output. You would design for the edge cases, so the boundary conditions of what that execution is actually supposed to do, and you can verify that your code actually does that. Super. The problem with iterators and writing unit tests is that, one, it's not an end-to-end invocation of your class, which is to say, how you write a unit test might not actually be how the tablet server invokes your iterator. So there's sort of that domain knowledge again. You actually have to know how the tablet server is going to run your code to effectively write a unit test that could cover all edge conditions. Most people don't do this. I don't think I could even tell you this off the top of my head. On the other side of the sort of spectrum here, we have the mini Accumulo cluster. This was a great little invention that came out probably at like the 1.5 timeframe. So what this actually is an embedded Accumulo instance that you can actually integrate with your testing framework. So it will stand up a encapsulated instance. You can interact with it just like you would a real system somewhere, and it solves the problem of unit tests is not having a representative identification. So we're actually using Accumulo itself. We're running your iterator through it just like it would on a real system, and you get to test it in that regard. This is nice, but there's a lot of headaches with it as well. It's very sort of pedantic to actually use. It takes a lot of time to actually write a test. You're essentially usually writing a lot of boilerplate to just say, how do I ingest data in a testing context? How do I get the data? How do I do all this other stuff before you even get to say, okay, now I want to test my iterator. And then usually by then I kind of get tired and don't want to write tests anymore. It also typically means that you have to have a pretty beefy machine to actually run these tests on. Pesky things like DNS actually become an issue then when you're running these. So if you have some remote build server, then suddenly, oh crap, it doesn't work there. So we kind of been trying in Accumulo to say, how do we answer, how do we sort of bridge the gap between these two things? We see an obvious gap in how we can test iterators, but how do we fix it? So back in 2012, our dear friend John Vines, who's up in Boston, I believe, had this idea of like, hey, we should write a fuzz tester for iterators. The general idea being we could take some general ideas, this general collective knowledge that we have about common things that people do wrong with iterators, and maybe we can actually represent these in some sort of framework and automatically test an iterator against it. So it really fits well in this sort of model we described, in that black hole between unit tests and mini Accumulo cluster tests. We can still do very fast unit testing. We can try to catch these edge conditions fast. We can actually reuse the test cases itself across multiple iterators, and we can actually let users or people who aren't working in the context of Apache all the time write their own test cases for common things that they've run into in their office, and hopefully they would share back with the community eventually. This approach still has some pitfalls. It has the same problems of unit testing in that the test cases imply the writer has to have an implicit knowledge of what Accumulo is doing. So we can encapsulate how Accumulo works in these test cases, but you still have to know that to write a new test case. And sometimes the failures of why one of these test cases fail might not be obvious. Even running an iterator in a system in production, you may not realize you had a bug in your code for 6 to 12 months after you've actually had it in production, and then you sit there and wonder, well, why does it fail 1 out of 1,000 times? We have the same sort of problem in trying to write a harness like this to do this sort of testing. But there's essentially sort of 3 things that you need to do to write a test in this framework. One is you need to define some input. So obviously you need some key value pairs that your iterator is expecting. So whatever schema your table has, you need to actually tell the framework, this is the schema of my data, this is some sample representative subset that I want to run the tests over. Similarly, you would also need to define some sort of range that says, when I read this data, ultimately it will generate this output as expected, and you would also provide that as well. Finally is a collection of test cases which the framework will run your iterator over your data and invoke these test cases on. By default, this will actually be picked up dynamically off the class path. So if you include the testing harness jar, you'll get 6 to 10 test cases automatically which will be invoked. If you're using JUnit4, you can use a nice parameterized annotation or parameter annotation, and it will sort of run all of these test cases out, break them out into nice little reported test results by Surefire, and that's pretty much that's the majority of the actual flow writing a test in this harness. So you might be wondering at this point, like, okay, this sounds like we're on the right path, but how do we actually have test cases here that we can write generically against all iterators? So there's a couple cases, and you have to be very specific in what you're actually trying to test in a way that is generic across all iterators. One of the first ones that I think I came up with is that if you write an iterator, you might not realize that you actually have to have a public no-args constructor on the iterator. If you're not using one, your IDE is probably going to complain at you if you have that constructor there or something that's not being invoked anywhere. So you might actually just remove it, actually deploy your iterator, and find out, oh crap, Accumulo just crashed my query because there was no args constructor on my iterator, and now you have to go back and fix it. Deep copy is one of the methods on the iterator interface. So, does a deep copy of an iterator actually operate independently of the source it was copied from? The iterator has top method. Again, it's supposed to be a stateless method, but if you invoke has top multiple times, does the iterator state actually change? Can we see that maybe if we invoke it 2 or 3 times, something actually happened inside the iterator that was unexpected and we didn't get the results we thought? The last is probably the most goofy sort of case where hitting back to the sorts of problems you don't find out until 6 months after you've been running in production. Inside of Accumulo, if you're running some query, Accumulo does have the ability to sort of tear down your scan session after you return a key value pair. And what that means is all your iterator instances get thrown away and they'll be reinstantiated the next time your client comes in and requests. The subtle implication of this is that your iterator will suddenly see a new range than what you initially passed in. It's a range that will still give you the correct data back, but your iterator might be expecting some range with a specific kind of start key, something that looks like this, and suddenly now your iterator doesn't work, and the next time you try to run your query, you might not even see that failure. So in an ideal world, right, we really want to make our lives as easy as we can. We want to say anytime we can write a better test that helps us deploy stuff faster to our systems and ultimately to your end users, that's valuable, right? So the quicker you can iterate and iterate with confidence, the faster your users of your system can actually see the value from what you're iterating on. The more we can actually encapsulate in automated tests, the better our lives are as developers, because now we don't have to worry about, is this change that I'm going to merge in going to break things? Is it going to make me get a call at 1 a.m. when something gets deployed out or some nightly job runs? And ultimately, it's just helping to reduce the debt that we have as software projects grow. And it really, at the end, I was kind of hesitant whether this whole idea would even be beneficial. And it turns out in the end, I actually really like the approach, and I think it really fits a great middle ground that we couldn't provide something, Accumulo itself as a product, to developers. I think it really fits nicely between unit tests and many Accumulo cluster tests to really create a much more comprehensive level of coverage for custom iterators that are being developed, as well as the ones we have in Accumulo. We can actually write these tests and run them internally so that we can catch bugs we wrote ourselves before you see them. So how does this actually look? If you have some, if you go home today and you say, okay, I have some iterators, I want to write this comprehensive test thing that Josh is telling me I should do. So one, you should already have some unit tests, right? You have some basic functionality. This is probably the one that everybody has. Many Accumulo cluster tests are great. You probably have something for them. They're great to run at sort of the integration test lifecycle. So referring to the Maven process. So this is actually not something you would want to run on every build because they do take a long time. They're going to take at least like 15 to 20 seconds. So these iterator test harness sort of tests you would wire up. They would be fast enough that you could run on every single build. They're going to be sort of like sub-second sort of things. So you have the confidence to not always skip all of your tests just because you want to do a build and get it out faster. So it helps us catch these sort of common problems that you might run into in production and then save yourself the hassle of having to turn around and immediately fix a bug, rebuild it, redeploy, and that's great. That really makes me happy because I couldn't tell you how much time I've spent redeploying code just because I did some dumb little bug that we could have caught with something like this. So again, end of the day, we have these set of 3 tests that we can run on builds, and eventually that's going to be our gate from going from source code to some artifacts, right? After that, we're going to have some amount of testing. Maybe we have some testing set up on our local machine where we can do just copy some jars locally, run maybe on a very small amount of data, run some application, run a job against it, and we can have some confidence, okay, it works on one machine. After that, we can deploy it to some staging machine, so you have like some small but maybe representative data set on a few nodes that you have up and running. You can say, okay, yep, it still works there. And then eventually, after you pass that test, you can then deploy it to production. But the goal here is to avoid that right side of the graph having to go back to the left. So we want to say after we get to each step, we don't want to have to revert because that's more time that we're wasting. We're wasting our own sanity then if we're constantly fixing dumb little bugs and then having to redeploy stuff all the time. So I really hope will come from this is that iterators lose this sort of stigma of things we don't understand how they work. I really think that they don't need to be. They're unnecessarily vague and hard to work with. And I think we can actually use this harness and this approach to increase the amount of confidence that we actually have in developing good iterators that are generally reusable by people other than ourselves. So again, it's a bit selfish because you're investing a little bit more time yourself, but if you can share that code then, other people get to benefit from that, and hopefully, someday the karma will come full circle and you'll get to pull something off the shelf later on. This harness really gives us a good framework in which we can sort of codify these common sorts of errors that we know as developers that people tend to do. We can catch them early before you deploy any jars anywhere and you waste any time doing that. And it really gives us a way that you can easily contribute these sorts of tests back to the community as well, in addition to the iterators itself. End of the day, you'll make your ops team and your QE teams happier because you can say, I have higher confidence in the code that I'm writing. I know that if I backport a change, it's going to work as I expect it to, and you're going to avoid the call to the people sitting by the phone waiting for something to break. And that's pretty much it for me. So I guess thank you for your time, and I hope to see a bunch more test cases here coming out for iterators, and if there's questions, I'd be happy to answer them.
So to what extent have you taken sort of Accumulo's internal iterators and written test cases using this framework for those iterators?
I can say definitively, I know I ran the whole row iterator, which is one that is commonly used. It's used a bit when we're actually reading from the metadata table itself. So the implementation of your client API. That was sort of my guinea pig as I was writing this harness itself. And I know that one was a good learning point because it fits this category of iterators which are general purpose reusable and not tied to a very specific schema. So that was one that I know has been running with the build since this feature was merged in. Oh, I should also say this is deployed in Accumulo 1.8.0. Another interesting bit is that you could actually use this new artifact in older versions of Accumulo. It's not tied to, so if you're still on a 1.6 or a 1.7, you could actually pull down this 1.8.0 artifact and use it in your local testing as well. I should have mentioned that earlier. I don't recall if I actually did commit other, wire up other iterators that we have in the source tree. I feel like I might have done one or two, but I couldn't give you names anymore.
Any other questions? All right, well, thank you, Josh. So we have about a roughly 10, 15-minute break until the next talk starts. So next in this room will be the Accumulo connector for Presto talk by Adam Shook and Dan Sun.